Are you interested in implementing runtime security for your host, cloud, container, or Kubernetes workloads, but aren't sure where to start? Hi, I'm Mike Coleman, a developer advocate on the Falco project, and in this video, I want to introduce you to Falco, a CNCF project that provides runtime security across a wide variety of platforms. Let's start by talking about the challenges that Falco addresses. If we go back several years to when most of our workloads were running in the data center, security was often equated with firewalls. The idea was we just needed to keep bad actors out. But today's operating environments are much more complex. We have workloads that run on-prem and in the cloud. They can be running on physical or virtual hosts. Maybe they're packaged into containers and are running on Kubernetes. Our workloads are no longer running inside a well-defined perimeter that we can easily secure. Because of this, we can't rely on old security paradigms. So today, we have an increased focus on secure software supply chains and shifting security to the left to ensure that security is baked into the end product from the start. These steps help ensure that we deliver software that is as secure as possible at deploy time. But what happens once those workloads are put into production? How do you know what was running yesterday is what's running today? How do you ensure that operators are adhering to operational best practices? This is where Falco and runtime security come in. If we go back to the firewall and think of it like a literal wall designed to keep people out, what do you use when they are able to scale that wall or perhaps are already on the inside? One tool in these cases is a security camera. Security cameras allow you to monitor what's happening in an environment in real time. And that's what Falco does. It's like a security camera for your workloads. It is constantly monitoring what's going on, evaluating those activities against a set of rules, and alerting you when something is out of order. So how does all of this work? On the most basic level, you can think of Falco as being based around three core activities. It captures events, it processes those events, and it outputs a message when something is suspicious. So let's take a look at each of those steps one by one. Falco can capture events from a wide variety of sources. Out of the box, we capture syscall events from the Linux kernel via a kernel driver. Monitoring the kernel not only allows us to analyze events that are happening on the instrumented host, we can also capture events inside of containers. This is because the container and host share the same kernel. So all the activity goes from the isolated container process into the host kernel where the Falco driver can capture it. There's a lot more I could say on how Falco interacts with the kernel, but we're limited on time today. I do plan on making a video in the near future on how the kernel driver works, so be sure to like and subscribe so you can be notified whenever that drops. In addition to the kernel driver, Falco also supports custom plugins as event sources. Currently, we have a bunch of plugins for things like Kubernetes audit logs, Okta, AWS CloudTrail, and Google Cloud Platform. These plugins allow events from the respective sources to be forwarded to Falco's engine for processing. So let's talk about that step now. Falco uses a ring buffer to pass the events from the kernel space into user space where they are processed. You can break this processing down at a high level into two different actions. The first is filtering. This is where Falco takes an event and compares it to a set of rules. By default, we ship with dozens of predefined rules. For example, Falco has rules to alert when someone accesses a sensitive file, or if someone runs a new process in a container that wasn't part of the base image. All kinds of different rules that help to ensure your systems are being operated securely. You can disable rules you don't want to use, you can modify those existing rules, and of course you can create your own. And just like kernel drivers, I plan on making a video on Falco rules, so stay tuned for that. Now, if an event triggers a rule, then we'll create an output message. This is where the second action happens, enrichment. I have a whole video on enrichment, and I'll link that in the description, so I won't spend a ton of time here. But basically, enrichment takes hard-to-read output from the original event sources and augments it with metadata to create easy-to-read output messages that the average human can understand. So we had an event that triggered a rule that leads to the creation of a message that then gets outputted somewhere. Falco by default supports a variety of endpoints including standard out, syslog, and HTTPS and gRPC endpoints. The easiest way to see Falco output is to check the Falco logs either from the Falco container if you're running Falco as a container or via the system logs. However, checking log files manually is not practical. So Falco has a companion project called Falco Sidekick which takes Falco output and sends it to dozens of different endpoints such as Slack, PagerDuty, Prometheus, Grafana, AWS Lambda, and so many more. Essentially, this allows you to start building out your own remediation and custom alerting in the systems that you are already using. So in summary, Falco could take input from the Linux kernel or via a plugin, it processes that data and sends it to a bunch of different outputs either natively or via Falco Sidekick. So there you have it, a quick introduction of how Falco provides runtime security, helping to ensure that your production workloads are running as you originally intended. You can find out much more about Falco over on our website, falco.org, or our GitHub. If you want to interact with Falco maintainers and users, you can join us in the Falco channel on the Kubernetes Slack. And finally, we host a weekly Falco community call, and you can learn more about that over on LinkedIn. Thanks for watching. Don't forget to like and subscribe to be alerted when we post new content, and I hope to see you on one of our various community channels very soon.